Welcome back. And this is one of the second video that I want to do on the concept of introducing Lowry Bronsted acid-base theory. Okay, now this may not be the only two videos. Okay, we are going to do more. So I just don't want to do too many just on the idea of allowing you to get used to the idea of writing positive and negatives. I think these two videos should help you get there fairly quickly. All right, now this is again like a primer just to get you started. All right, now again, this is carbonic acid. Now for people that are into drinking soda products like Pepsi, Coke, Dr. Pepper, any of those, they all contain carbonic acid, okay, which is what gives that fizzing effect, because carbonic acid is very unstable in water, and then it makes carbon dioxide and more water, okay? And that's the carbon dioxide that you feel when you drink or when you open the bottle, okay? It's basically this compound right here, carbonic acid, okay? Now, if you notice, there's something different. There's two hydrogens. Well, normally compounds with a lot of hydrogen is an acid, okay? So this is the acid, and this is the base. So because we're starting with a compound that has two hydrogens, we have to write we will be writing two equations, okay? And I'll actually walk you through how to do this. So we will have two different Ka expressions, okay? Because this is a weak acid, okay? And we're doing a double-headed equilibrium, so we're going to be doing an acid dissociation constant. So what happens here is, first, the acid, again, Lowry Bronsted means acid donates proton, right? Acid donates proton. Again, I may not keep saying this every single time. You have to get used to it. Eventually accepts proton, right? So it donates one proton, right? So what happens then is, again, right, without the proton, it has lost one proton, right? So 1 minus, plus it's got one proton. Again, if you want to write that alternate option that I said you should not write, then go ahead and do it, but this is the correct way to do it. It's got that one proton, so it's receiving the proton, so it's receiving the positive charge, so it's 1 plus. So if this was acid, this should have been conjugate base. Because this is base, this is conjugate acid, okay? Carbonic acid is acid, so that's A, so this must be B. If this is A, this must be conjugate base. This is base, means this is conjugate acid, okay? Don't worry, we're going to do plenty of work in class, so you still have to watch the video, but I will get you up to speed, all right? So it's not something you have to worry right now. All right, so now what happens here is, because we started with two hydrogens and we used only one of them, now this, again, can react with another molecule of water. Not with H2, H3O plus, that's it, that's over. It can react with another molecule of water. Again, water is always liquid. Anything else is aqueous, okay? So just keep that in mind. Now this can donate, so this is now acid again. This is base. Well, water is always going to be base because we started with an acid, so water is always going to be base in this side, okay? Now again, there's going to be a proton transfer, and I'm going to switch colors so you can see it better, okay? Because it already had, so right without the proton, that's the easiest way to do this. You already had one negative, right? If you're going to lose one more proton, it's going to become 2 minus, plus, again, this is getting only one proton, so this is going to be H3O plus. Again, sorry if I didn't write it as double-headed arrow, it should have been double-headed. So if you start with two hydrogens, then you have two processes. If you start with three, then you go through three processes. So how do we write the Ka expression for this? Well, because there are two successive steps. Oh, let me finish this one. So this is acid, so this is conjugate base. If this is base, this is conjugate acid. as I said, the way I would ask you is, again, I don't want to do this on here, but I would do this in class, okay? But you have to understand the two videos before you can really work it out, all right? So again, this is an acid, and it's a weak acid, so it's an acid, because we're starting with an acid, is acid dissociation constant. But because there are two steps, let's call this step 1 and step 2, we're going to not just say Ka, but Ka1 and Ka2. Ka1 is the first step, which is, again, ratio of concentration of products. Write everything the way they look. H3O plus 1 and divide by only H2CO3, no water, because you cannot have pure solids and liquids. This is an equilibrium expression. You cannot have that in there, all right? Ka2 is what's in the second equation? Well, you have CO3 2 minus and H3O plus divided by HCO3 minus. Now, we could do a titration. Actually, I think we did do a lab on the soda, but if you actually have a pH meter to track it, then you will see that there are two bends, which again, I don't want to get into it because we are going to come back to this concept in a different view when we actually deal with acid-base titrations. Okay, but for now, we're on Lowry Bronsted acid-base theory. And so you have two different Ka expressions. Now, if you remember when I introduced the concepts of acid and base, I said water can behave both as acids and bases, okay? It doesn't matter which one of the water is acid and which one is base. I always write the first one as A, second one is B. Now, if you notice, they're both water, okay? So if it's acid, that's the one that's going to lose the one proton, right? So it's H3O plus, right? Oh, actually, if it's lost it, let's do it this way. Okay. All right, so this has lost a proton, so you write OH, right? It's lost one proton, so it's 1 minus, plus it's got that one proton, so it's going to get the positive charge, so H3O plus. Now, you don't need to do it the second time because this is where it stops. You ask me why? Well, I'm telling you that's where it stops. All right? So now this is interesting. You don't rather say Ka nor Kb because, well, both are reactants is water. So we have to come up with a unique name. It's neither Ka nor Kb. It's called Kw. Please don't forget this. Of course, this particular expression will be on the appendix because this is kind of like universal equation that you need to know. Now, why are we not dividing by the denominator? Well, they're both liquids. Anything with ions is aqueous. So aqueous can go in the expression, just not pure liquids and pure solids. Okay, this is called Kw. I'm going to box this in a different color. This is very, very important. We're going to come back to this expression. This is called self-ionization of water. This whole thing is called self-ionization of water. And this is where I want to stop and then actually bring you up to speed in class on this topic. Okay, you see Kw is H3O plus and OH minus. This equation is as foundational as it gets when we are decided to talk about the concept of pH and POH. Okay, the concept of pH and POH is pretty much something you should know. And so this is the only expression that you will find in the appendix on this concept of Lowry Bronsted, simply because it's an expression that must be given. Now, while I'm on this, I'm going to give you one thing. This Kw has a value of 1 times 10 to the negative 14. If you're not familiar with exponents, then that leads to a whole issue of calculator-based issues. So we're going to fix all that through some work. But there's two things that I don't want you to remember is this Kw expression and the actual value of Kw. This is the ionization of water constant. This is 1 times, Let me actually write it in black. 1 times 10 to the negative 14. All right. So we're going to do some examples and get you up to speed on able to write conjugate base, conjugate acids, and get used to the idea of acids and bases through the videos I've just posted. And again, I'll be posting more videos on this topic, but these 3 or 4 videos that are part of this collection is very, very important to get you started. And then moving forward, we'll do some math and related concepts. Right. Stay tuned for more videos on acids and bases.